Okay, in this video we'll begin the last set of problems in this section on limits at infinity. Number 19. As x goes to infinity, then 3 over x is going to become 0, and that limit will be 4 plus 0, which is just 4. 21. We have the same degree in the numerator and denominator, so we just divide the leading terms 2/3. 23. We have a larger degree in the denominator. That limit will always be 0. 25. You have x squared in the numerator, x in the denominator. You have a higher degree in the numerator. Limit does not exist. Okay, in problem 27, 28, 29, we have a sort of unique condition here. You may recall, and hopefully you do recall, this fact from Algebra 2, Pre-Calculus, wherever it came up, that the square root of x squared is equal to the absolute value of x. Well, what does that mean? X could be positive or it could be negative. When we square it, though, it will always come out positive, and when we take the square root of that number, it will always be positive. If in the event that x started out negative, we couldn't say that the square root of x squared is equal to x, because that number would be positive and x started out as negative. So we always have to say that the square root of x squared is equal to absolute value of x. Let's give a quick example. Let's say we started out with x is equal to -2, and we have the square root of -2 quantity squared. Well, when we square -2, we're going to get positive 4, and the square root of 4 is 2. Note that we didn't end up with the -2 that we started out with, but we have the absolute value of that -2, which is 2. So square root of x squared is equal to absolute value of x. So in problem 27, in the denominator, you have the leading term being square root of x squared, and so that's absolute value of x, whereas in the numerator you have x. So you end up with something like x over absolute value of x. Now, when x is positive, those two things will both be the same, and you'll get a 1 there. However, when x is negative, the numerator is going to be negative, and the denominator will always be positive, so you'll end up with -1. So the limit at positive infinity of that expression would be 1. The limit of negative infinity at negative infinity of that expression would be -1. So these types of problems will have a different horizontal asymptote or a different limit at infinity as you approach positive infinity and negative infinity. So that's why this number 27 is approaching negative infinity. That answer will be -1. Now in 29 we're also approaching negative infinity, but there we have 2x over absolute value of x. And so this one will be 2 times the -1 or 2 times the +1. So as we go to negative infinity, this one is going to be -2. Now in problem 31 we just have the radical expression on the top, but that would still be square root of x squared over 2x, and so that would be absolute value of x over 2x. And so as you go to positive infinity, both values, x's numerator and denominator, will both be positive, and you'll get a value of 1/2. With 33 it's a little bit complicated, but you have x squared, and that's going to be raised to the 1/3, so that would really be x to the 2/3 power. So x squared to the 1/3 is equal to x to the 2/3, which is a smaller power than x to the first in the numerator, so numerator has a greater power. Limit does not exist. Now in 35 and 37 we have trigonometric functions, and what's going to happen in the denominator of 35 is the sine of x is going to oscillate between -1 and 1. But 2x, x going to infinity, is going to become so large that that little oscillation is not really going to change anything, and so it's 1 over very large, and that will be 0. Similarly, in 37, even though it's sine of 2x, that's still going to oscillate between -1 and 1, whereas the denominator is going to grow infinitely large, so the limit at infinity will be 0 also. And that wraps up all we need to do for limits at infinity.